Let us look at the next example. So here, for example, V1 and V2 are the same. Again, this one is 0. This one is 0. You don't have current. This one is 0 ampere. Same for this one. And V1 and V2 are the same. V1 equal V2. V2 equal 9 volt. So this one will be 9 volt. Both of them will be 9 volt. Okay. Then apply nodal analysis at the input. So you have 3 currents. 1, 2, 3. The third one is 0. Okay. So the first current, which is this one here, this one, is what? Is V1, that's 9, minus this voltage here, which is 24. This voltage is 24. Okay, so it will be V1, that's 9, minus 24, divided by the resistance, which is 5. Second current, which is this current here, which is the same like IO, this IO. This IO, VO equals this current equal what? Equals this voltage minus this voltage. This voltage here is V1. V1, that's 9 volt. And this voltage is VO. Okay, so it is V1 minus VO divided by 2. And remember again that V1 is 9 volt. So here we have one equation and one unknown, which is VO. Then you can calculate it. For this example, let's look at this example. Again, this current is 0. This current is 0. This one is 0. Okay. And this voltage equals this voltage. They are the same. Do I know any one of them? I don't know. This one is not. Is it 9? This one is 9. I know that the voltage here is 9 volt. For sure. Because of the source. Because I know this one is 0. This one is 0. Where is this? And write it again. So this one here is 0. Because this is a ground. So you have a 0 volt here. And this 9 volt. Okay. So what about the voltage here? The voltage here will be also 9 volt. Why it is 9? Why it is 9? Because the current is 0. The current, this current equals 0. This current is the same like this one here. This current in this direction here is 9 volt. It is, sorry again. It is. So this current is 9 volt, is 0, which is this one here. So this current is 0. Then the current in the 7 ohm is 0. Then there is no voltage. Again, according to Ohm's law, here is Ohm's law. V equal I times R. I is 0. Then the voltage will be 0. Then there is no voltage across the 7 ohm. Since there is no voltage across the 7 ohm, if this one is 9 volt, the same, this one also will be 9 volt. And if V2 and V1 are the same, then in this case V1 is 9 volt. 9 volt. Okay. And then you apply, next step, to apply nodal analysis at the input. So this current here, this current, plus this current, which is this one here, plus the third current, which is 0, equal 0. Okay. So in this case, if you want to write the equation, so the first current is V1 minus, this is 24 volt. Okay, so it will be V1 minus 24 over 5, and V1 minus VO over 2 will be exactly the same like this one here. There's no difference between this one and this one. So the first top circuits are the same. There's no difference. This 7 ohm will not make any difference. Why? Because there is no current. There is no current in the 7 ohm. Okay, so you will have the same result. There is no difference. Let us look at the next one. Let us look at the next one, this one here. Okay. Here we have a current source. That's it. There's no difference here. This one is 0 again. 0, 0. Okay. And the voltage here equals the voltage here. Both of them are 0 because this is V2 is connected to the ground. So if V2 is 0, V1 is also 0. Okay. Then if you apply nodal analysis at V1, then you will have this current plus this current plus this one, which is 0, equals 0. So if you want to write this one, this current is negative 3. Yeah, here it is. It is negative 3. The first current is negative 3. Second current is V1. This is V1 minus this voltage here is VO. So this is V1 and this is VO. So V1 minus VO divided by 2. So this will be the second current. Okay, negative 3 plus V1 minus VO over 2 equals 0. And you know that VO equals 0. Then now we have only one unknown, which is VO. Let us look at the second example. I added here this 7 ohm. Then we follow the same steps. This current equals 0. And this voltage equals this voltage. V2 is connected to the ground, so V1 will be also 0 volt. Okay, and then you apply nodal analysis at V1. Then this current, which is negative 3, plus this current, that is V1 minus VO divided by 2. So you add these two currents will be 0. The first current is negative 3. Second current is V1. This is V1 minus this current here, this voltage here, which is VO over 2 equal 0. Okay. So again, you see here, this one here will have almost the same result here, like this one. Why? Because the 7 ohm, for the 7 ohm, the current is the 7 over 3 ampere. So because if you have a current source here, then if you have this 7 ohm, will not change the current. Will not change the current. Let us look at the last example. The last example, you have this circuit here. So let's see, we'll apply the same steps again. Blindly, you apply the same steps. This is 0. This one is 0. 0 ampere. This is 0 ampere. And this voltage and this voltage are the same. Okay. This one here again, you have the same current here equals 0. This current equals 0. So this 7 ohm as it doesn't exist. So if this one is 18, this one is 18 volt because of the source. So V2 also is 18. Then V1 and V2 equal 18. Both of them equal 18 volt. Why again? Because this current equals 0 ampere. So if you have 0 ampere times 7 will be 0 volt. So this point and this point will have the same voltage. There is no difference. This one is 18. This one is also 18. Then you apply nodal analysis at the input. So this current here, which is negative 3, plus this current, which is V1. Here's V1 minus this voltage here, which is VO, divided by 2 equals 0. So negative 3 plus V1 minus VO over 2 equal 0. V1 is 18 volt. Then you have only one equation and one unknown. One equation and one unknown.